Alright, this video we're going to take a look at how to solve an angle side-side triangle using the law of sines. Angle side-side, also known as the ambiguous case for the law of sines. It's called that because depending on the values you're given, you may end up with one triangle, two triangles, or no triangles. And while there are quicker ways to check, I'm not going to really cover those in this video because I'm going to come up with a sort of a generalized way of answering these questions. But back in geometry days, you learned about side, 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 and side, angle, side, and angle, angle, side, and angle, side, angle. And if you're given those pieces of information, for instance, three sides of a triangle, you only get one possible triangle if you're given the lengths of three sides. So with those cases, and with angle side angle and angle angle side for law of sines in general, you only get one triangle out of those. But with angle side side, you could get one, two, or none. So here's the techniques we're going to use to help us out. A couple things. Number one, the angle sums of a triangle is 180 degrees. That's going to come into play. Also, that the sine of an angle, in the second item here, the sine of an angle is equal to the sine of the supplement of the angle. So for instance, if x is, let's say, 50 degrees, the sine of 50 degrees is the same as the sine of 180 minus 50, which is 130. And you can verify that on a calculator. The sine of 50 and the sine of 30 give you the exact same answer. You can also use the angle difference for sine to prove that as well. And then finally, number three, the domain of our inverse sine is between -1 and 1. And because we're dealing with side lengths of triangles, we are actually going to even make it even more restrictive that when we take the inverse sine of a ratio of an answer, it has to be, well, greater than 0, not greater than or equal to, but less than or equal to 1. So we're going to use these three to help us out for the examples we're going to look at. So example 2, solve each of the following, round our answer to one decimal place. So we have angle A is 30 degrees, side A is 1, side C is 4. So I'm going to start by sketching a triangle. And it doesn't have to be very accurate because it's just a sketch. And we know A is 30 degrees, and side A is 1, side C is 4. I'm just going to copy this to make life a little bit easier for me here. We'll see why after this example. And in this case, side A, opposite angle A, is 1. So the first thing we need to do with angle side side is we're going to have to find the angle opposite one of the known sides. So we're going to start with sine of 30 degrees over 1. So the sine of angle A, sine of 30 degrees over 1 equals the sine of angle C over 4. So when we cross multiply, we get 1 times the sine of C, which is just sine of C, equals 4 times the sine of 30 degrees. Now 4 times the sine of 30 degrees, sine of 30 is a half, so 4 times a half is 2. So we have the sine of angle C equals 2. So C is going to be the inverse sine of 2. And when we try to take the inverse sine of 2, we get a domain error because we can't take the inverse sine of 2 because when we take the inverse sine of a number, it has to be less than or equal to 1 in this case. So in this problem, because we are trying to take the inverse sine of a number bigger than 1, that can't happen. This problem here is actually not a triangle. In other words, if you were to try to make this in real life with the exact measurements that it was given to you with a 30-degree angle and 4 and 1, you would not be able to draw a complete triangle. Your three sides would not connect. So right off the bat in example A here, we do not get a triangle, and that's because we're trying to take the inverse sine of a number that is larger than 1. So now let's take a look at part B, where the only difference is now side A has a length of 2. So I'm just going to paste my sketch, and now side A has a length of 2. So we're going to set this up very similar to how we did before. The sine of 30 degrees over 2 equals the sine of C over 4. And when we cross multiply, we're going to get 2 times the sine of C equals 4 times the sine of 30, which we know from the last example is 2. So 2 times the sine of C is 2. So if we divide both sides by 2, these will cancel out. We get the sine of C is equal to 1. And when we do inverse sine of 1, we actually will get an angle. And the inverse sine of 1 is 90 degrees. So angle C is 90 degrees. And for this one, because it is 90 degrees, I'm just going to re-sketch it. So now I'll make it a little bit more along the lines of what it would look like. So I know A is 30 degrees, C is 90 degrees, side A is 2, and side C is 4. So what we have here is a 30, 60, 90 triangle. Angle B, if you take 90 and 30 and add them up, you get 120. Take 120 away from 180, angle B is 60 degrees. And we can shortcut this because if we know the properties of 30, 60, 90 triangles, we can make this really quick. Opposite the 30 degrees is 2. Opposite the 60 degree angle is going to be that 2 times the square root of 3, which in this case gives us about 3.5. So we could also get that if we did sine of 30 over 2 equals the sine of 60 over b. We're going to get about 3.5, we get the same value there. But just recognizing the 30, 60, 90 triangle, we can get the job done a little bit quicker. All right, part C, we've got 2 more here. This time A is 3, so we're just increasing A by 1 for these examples. So this time A is 3. And I'm going to start this once again. The sine of 30 degrees over 3 equals the sine of angle C over 4. When I cross multiply, I get 3 times the sine of angle C. And once again, 4 times the sine of 30, just shortcut that, is going to give us 2. So if we divide both sides by 3, we get the sine of angle C is 2/3. So we're going to do inverse sine of 2/3. So angle C is the inverse sine or arc sine of 2/3. And that's going to give us approximately 41.8 degrees. Now, in our little toolbox here, we have in line 2 the sine of an angle, x. Sine of an angle is equal to the sine of the supplement, so 180 minus x. And what that means for us is there's actually 2 values whose sine is equal to positive 2/3. One of them is the sine of 41.8 degrees. That gives you about 2/3. The other one is we take 41.8 and subtract it from 180. 180 minus the 41.8 will give us an angle of 138.2. If we do the sine of 41.8 in our calculator, it's going to give us the exact same answer as the sine of 138.2. Now, here's where we need to also keep in mind that, again, the angles of a triangle are going to add up to 180 degrees. The 41.8 degrees for angle C, there's no problem there. We have 41.8 plus 30 degrees. We got some angle left over for angle B to add up to 180. But now let's take a look at what happens if we put in 138.2. If we do 138.2 for angle C, 138.2 plus the 30 degrees we started with is 168.2. There's still some angles to add up for B, left over for angle B, so our triangle adds up to 180 degrees. So because plugging in the 2 values of C leaves us with a value, a total less than 180 for angle, for the triangles that add up to 180, there's actually 2 possible triangles we can draw with that given information. The first case, so case number 1, is angle C is 41.8 degrees. And if we make angle C 41.8 degrees, sorry about that. Angle C is 41.8. We also know that this was 3. So to find angle B, we take 180 minus 30 minus 41.8, and angle B comes out to be about 108.2. So now to find side B, we use sine of 30. Always use the information that you were given. Don't use any information that you rounded with, like the 41.8. Sine of 30 over 3 equals the sine of 108.2 over B. So when we cross multiply, we get B times the sine of 30 degrees equals 3 times the sine of 108.2 degrees. And if we divide both sides by sine of 30 degrees, what we'll end up with is approximately 5.7 for B. So in this first case, where angle C is 41.8 degrees, angle B is 108.2 degrees, and side B is about 5.7. That's our first case. For our second case, we're going to look at what happens when angle C is 138.2. So I'll just re-sketch that. Just paste it down here. This was 3. Now let's see what happens when C is 138.2 degrees. Well, 138.2 plus 30 is less than 180, so there's still some angle, some degrees left over for B, and 180 minus 30 minus 138.2 gives us 11.8 degrees for angle B. So we'll set it up with the sine of angle A, the sine of 30 over 3 equals the sine of 11.8 over side B. So B times the sine of 30 equals 3 times the sine of 11.8. So dividing both sides by the sine of 30 again, this time we get B is about 1.2. And again, note that the smallest angle should have the shortest side opposite. So in this triangle, angle B is 11.8 degrees. That's the smallest angle. It's opposite the shortest side at 1.2. Angle C is the biggest angle, 138.2. It's opposite the longest side of 4. So we have 2 triangles in this case because inverse sine of 2/3 could be 41.8 or 138.2. And if we check each one of them, there's still some room left over for angle B. Now, if the second angle of 138.2 plus the first angle of 30, if that didn't add up to be less than 180 degrees, then only the first angle would work. So in that case, we would only have one triangle. But because 30 degrees plus 138.2 is less than 180, we have 2 possible triangles. One where angle B is 108.2. The other where angle B is 11.8. All right, our last example, this time we have A is 4. So I'm just going to paste this in. And this time A is 4. And just a quick tip here is that notice we have from A to B is 4, from B to C is 4. We have an isosceles triangle. So that's going to force the angles opposite that those equal sides to be equal. So if this 30 degrees is opposite 4, this also has to be 30 degrees. And if we did our setting up sine of 30 over 4 equals the sine of C over 4, and you went and did the multiplication. 4 times the sine of angle C equals 4 times the sine of 30, which we know is 2. So dividing both sides by 4, you get the sine of angle C is a half, which means C is going to be 30 degrees, or 150 degrees. Because remember, the sine of 30 and the sine of 150 both give you a half. But if we plug in 150 degrees for angle C plus angle A is 180 degrees. That's not going to leave anything for angle B, so we can't possibly have two triangles in this case. We only have the one. So A is 30, C is 30, using the fact triangles add up to 180 degrees. Angle B would have to be 120. Then to find the measured side B on the base there, we have sine of 30 over 4 equals the sine of 120 over B. So cross multiply. Oops, too much there. Cross multiply, we get B times the sine of 30 equals 4 times the sine of 120. Not equal to 2. Divide both sides by the sine of 30. And you get approximately 6.9 for side B. So that's how you handle the angle side case for law of sines. Thanks for watching. Don't forget to like and subscribe, hit that bell notification, and I'll see you in the next video.